Hello, all of you. For the today's session, we are going to discuss first application of a dimension or dimensional analysis, or the first application of the dimensional analysis. So, the first application is to find out or to find correctness of a or of any physical equation for any physical equation now first of all, just try to understand the meaning of this particular statement, and then we'll go forward for this application of dimensional analysis, right? So application that we are just talking about over here. So first of all, just try to understand what equation is. From the 8th standard, or in the 8th standard in the mathematics, we already studied about the word equation is equation and expression. Let me give you example over here. For example, say x square plus 5x plus 4, and another example let me give you, that is x square plus 5x plus 4 will be is equals to 0, right? Now apart from these two examples, example number 1 and example number 2, which example we can keep in the above mentioned these two category? Tell me. Which will be the we can consider it as equation, and which we can consider it as expression? You can easily answer that particular question. So how could you just answer this? You may say that, so wherever the whatever we can say that terms are, we can say that they are connected by the equal sign. Here this x square is a term, right? 5x is also a term which contain constant plus variable. This is also a term which is only a constant, right? Then these three terms are connected by the mathematical operator, that is plus, and then equal sign is present. Wherever we can say that such a terms are connected by the equal sign and the mathematical certain operators, so equal sign is a must. So when the equal sign is supposed to come, then it becomes equation. So we can say that x square plus 5x plus 4 will be is equals to 0 is considered as the equation, right? Now next one, expression is what? Only terms, only we can say that variable with a constant, if they are just present over there in that particular case, then we can say that this is only a expression. It doesn't have any equal sign, so it can be considered as a expression. So I think you got the idea that why we can call it as a this particular nothing but a mathematical thing, or this is considered as equation, and why it is the expression. Now equation consists of a equal sign, but we are not talking about the mathematical equation, we are talking about a physical equation. Now what were the meaning of physical? Let me explain to you. Physical means whatever around you is considered as a physical, right? So whatever around around you considered as a physical means, in other word, we can define that with the help of our five senses, whatever you are going to sense with the help of our five senses, that can be considered as a physical, right? So the word meaning physical is nothing but a whatever you are going to we can say that sense with the help of five senses is considered as a physical. So the world around us is considered as a physical world, right? But what do you mean by, we understood physical means what, we understood equation means what, but what is a physical equation? That we need to study over here. So physical equation is What it is? It is any physical phenomena or any phenomena coined with, or any phenomena described with described with a formula, described with a formula, or described with a equation, then that description of that particular physical phenomena, or that description of a phenomena in terms of formula, or description of this phenomena in terms of equation. So the equation which describes the physical phenomena, that means, let me give one example. If you are just moving with a certain velocity, if here you are, right, and I'm over here, say here I am, right, so right, I'm here, right, and you are just moving from this point to this particular point. So you are just running something like that. Here, say, supposed to be, say, your velocity is u is equals to, say, 10 meter per second, right? And afterward, you are just going to, we can say, I'm observing you, and you are just moving faster right now. You are just going to increase your velocity. So final velocity, say, it is denoted by letter v, and say your final velocity is, say, 15 meter per second. That means within this particular time period, or within this two particular position, how much is the displacement covered by you? That is equal to, say, s is what? Displacement. U is initial velocity, v is the final velocity, s is the displacement. So how to connect this phenomena, how to connect these particular terms? So there is a physical equation, kinematic equation, we can say that v square minus u square will be is equal to 2 into a into s. This is nothing but a kinematic equation, and this is third kinematic equation. मराठीमध्ये याला गतिविषयक समीकरणे म्हणतात. 9वी किंवा 10वी मध्ये तुम्ही शिकले असाल गतिविषयक समीकरणे. आणि काय म्हणतात आपण इंग्लिश मध्ये याला आपण म्हणूयात कायनेमॅटिक इक्वेशन. वी कॅन call them as a kinematic equation. So these are the equation. Not only these equations are considered as a physical equation. There is equation like force is equals to mass into acceleration. What it tells you, if you apply a force, object will get accelerate, object changes its velocity. Then this formula is also considered as a physical equation, because it tells you what happens when you apply a force on any physical body. So this equation also can be considered as a physical equation. This equation is also called as a physical equation. मग तुम्ही म्हणाल की सर ह्या ऍप्लिकेशन मध्ये जे आपण काय बघतोय, टू फाइंड द करेक्टनेस ऑफ द फिजिकल इक्वेशन. सो दिस इक्वेशन इज राइट और रॉन्ग, this equation right or wrong, that we can find it out with the help of dimensions, or with the help of dimensional analysis. Now how to find out, what is the procedure to find out whether that particular equation is right or wrong? Let me give you the three kinematic equation. First kinematic equation is equal to v is equal to u plus a into t. Now what is v? First of all, let me give you u. U is initial speed or initial velocity, right? Then u is what? U I already told you, u is initial velocity. V is final velocity. Final means after particular time interval you may get speed get increase, or you may get decrease. That means if you are just moving with a 10 meter per second velocity, and you are just suddenly increasing your speed or your velocity, that means this is your initial and this is your final. Initial is denoted by letter u and final is denoted by letter v. Now a is what? Acceleration. A is acceleration. And t is what? Time taken to change the velocity from u to v. What is t? T, time taken by that particular object to change its velocity from u to v. Now this is first kinematic equation. Now whether it is right or wrong, how to check it out? Let me give you little afterward. Let me give you that information little afterward. Second kinematic equation is s is equal to u into t plus 1 by 2 a into t square. Now what s is? You know that u is what? You are aware of that a is what? Now s is equals to, this is called as a displacement. S is displacement. That means it is a length covered by u in a certain time t. So displacement. Now this is second kinematic equation. Now third kinematic equation that I told you, that is v square minus u square equals to 2 into a into s. This is the third kinematic equation. V is what? Final velocity. U is what? Initial velocity. 2 is the constant. A is what? Acceleration. And S is what? Displacement. So all these physical quantities I explained to you. Now we are quite aware of that the dimensions of this particular quantity. Now how to use our analysis, dimension analysis, to find out whether that particular equation right or wrong. So I am going to take a first kinematic equation, that is V is equal to U plus AT. Now what is the procedure? First of all, you need to take a right hand side. Take a right hand side first. Okay, and write that right hand side first. I wrote the right hand side. Now later on you need to find out the dimensions of right hand side. So dimensions of right hand side is nothing but a dimensions of U plus dimensions of A into, because A and T are multiplied, so that's why the dimensions of these two factors also get multiplied. U is added to AT. U आणि AT यांचं काय ऍडिशन आहे म्हणून त्या दोन डायमेन्शनचं सुद्धा ऍडिशन लिहिता येईल आपल्याला, राईट. लेट मी गिव्ह द डायमेन्शन्स ऑफ U. Dimensions of U is a speed, U is a velocity, then dimensions of U will be equal to L raised to 1 T raised to minus 1. Dimensions of we can say that velocity, final velocity, it is a velocity, that's why its dimension will be also same, that is L raised to 1 T raised to minus 1. Dimensions of acceleration, that is equals to L raised to 1 T raised to minus 2. This already I gave you, this dimensional formula I already gave you in the previous session. Now dimensions of T will be is equals to T is the power is here, it is a 1, that's why dimensions of T will be is equals to 1. Place the value of this all dimensions over here. So what exactly you will get? Dimensions of U I am writing, that is L. What is dimensions of U? That is L raised to 1 T raised to minus 1. T raised to, say, we can say that minus 1. This minus sign is important, right? Then plus sign, plus sign. Dimensions of acceleration, that is L raised to 1, right? T raised to minus 2 into dimensions of T, dimensions of this factor T. T is equal to what? T raised to 1, right? Now what to do? L raised to 1 T raised to minus 1 will be remain as it is, plus sign will be remain as it is, this L raised to 1 will also remain as it is, this T raised to minus 2 I am writing as it is. And now I am going to take, because here they have a multiplication sign, that's the reason why you can take these dimensions in this bracket. Otherwise if here it is addition sign, you cannot add the dimensions of this factor, total factor, to this factor, right? So you can keep it, that is keep this thing in mind, that whenever there is a multiplication between the two brackets, then and then you can take the same term together, otherwise it is not, right? So T raised to 1 I am taking together, and T raised to minus 2, right? So L raised to 1 T raised to minus 1 will be as it is, plus L raised to 1 minus 2 plus 1, bases are same, then indices are get added or subtracted, right? So this way you can go like this. Now what is there? This particular term will be remain as it is, L raised to 1 T raised to minus 1 will be as it is, plus L raised to 1 as it is, minus 2 plus 1, that means 1 minus 2, 1 minus 2. So 1 minus 2 is nothing but a minus 1, because we can't subtract 1, we can subtract 2 from 1, so we'll take a 2 first, then 1 later. 2 minus 1 will be equal to 1, but this factor is not like that, this is 1 minus 2, and that is equal to minus 1, right? So T raised to, it will be minus 1. Now one thing is very important for you, here we have a same dimensions, here we have same dimension, here also we have a same dimensions. When such a two same dimensions are get added, when such a two same dimensions are get added, then addition of the same dimensions will be is equal to same dimensions. You need to keep only as it is, no need to modify later on. Why, how it is? Let me give one example. 10 meter per second minus 2 meter per second, how much it is? It will be 8 meter per second. That means meter per second minus meter per second again will be the meter per second. Same way, same dimensions plus same dimension, or same dimension, maybe if it is other in any another equation, like over here we have v square minus u square, that means here also will get the same dimension minus same dimension, then you will get a same dimension over here, right? So like that. So we have a dimensions of right hand side, yet our problem is not solved, the dimensions of right hand side is we got. Now take a left hand side. take a say left hand side. So what is the left hand side? In a left hand side we have only v. What is this equation we are talking about? We took the dimensions, we calculated the dimensions of right hand side. Now calculate the dimensions of left hand side. So what is the left hand side? We have v. So dimensions of left hand side, because dimensions always write in the square bracket, right? Dimensions of v, and I already gave you the dimensions of v, that is equal to L raised to 1 t raised to minus 1, right? So dimensions of left hand side is L raised to 1 t raised to minus 1. Name it this equation as 1. Name it this equation as 2. So dimensions of left hand side will be is equal to dimensions of right hand side. So from equation 1 and 2, from equation 1 and 2, what we can say that dimensions of how we can say that to square bracket, dimensions of left hand side is equal to dimensions of right hand side. When such a thing happens, म्हणजे ज्यावेळेस डायमेन्शन्स लेफ्ट हँड साइडचे डायमेन्शन्स आणि राईट हँड साइडचे डायमेन्शन ज्यावेळेस इक्वल असतात, त्यावेळेस आपण काय म्हणू शकतो, that time we can call it as a the given equation is dimensionally correct. म्हणजे डायमेन्शनचा यूज करून आपण फाइंड आउट केलं, डायमेन्शनली काय फाइंड आउट केलं, ते दिलेलं इक्वेशन्स काय राईट आहे. मग जर असं त्या इक्वेशन मध्ये कोणतं इक्वेशन होतं, दॅट इज v is equal to u plus ad, and as v is equal to u plus ad, in that particular condition, if the dimensions of this part, dimensions of right hand side part and dimensions of left hand side part जर इक्वल जर आला, तर त्या कंडिशन मध्ये काय म्हणायचं आहे, ते इक्वेशन काय करेक्ट आहे, अदरवाइज इट इज नॉट. बट हे आलंय ना आपल्याला काय म्हणतात, आपण इक्वेशन 1 वरून आणि इक्वेशन 2 वरून आपल्या लेफ्ट हँड साइडचं डायमेन्शन्स आणि राईट हँड साइडचे डायमेन्शन्स आपल्याला इक्वल आणि करेक्ट आले. सो इन दॅट पर्टिक्युलर केस वी गॉट द आयडिया दॅट डायमेन्शन्स आर करेक्ट. सो अशा पद्धतीने आपल्या डायमेन्शन्स शोधता येईल. तुम्ही इक्वेशन सेकंड कायनेमॅटिक इक्वेशन आणि थर्ड कायनेमॅटिक इक्वेशनचे डायमेन्शन्स मला होमवर्क मध्ये आज सॉल्व्ह करा किंवा उद्या सॉल्व्ह करा आणि उद्या मला व्हॉट्सअपला पाठवा. ठीक आहे, थँक्यू.